this lecture, we will try to solve one problem based on the connections of two-port networks. So, this problem is given where you have to determine the y parameters of the given network. So, suppose if you don't think about the connections of two-port networks, it will be very tough to solve this problem because there will be several nodes, several loops if you consider mesh equations, and if you consider nodal equations, we will have several nodes. So how to avoid it? How to avoid this? How to simply solve this network? Using the concept of connection of two-port networks. So we need to divide the given network, the overall network, into two different networks. So you need to observe for the type of connection first. So it doesn't mean that since y parameters are asked, the networks will be in parallel connection always. They may not be, but here it is happening. It's fine. So that means first you check for parallel connection. Since y parameters are given, okay, first you check for parallel connection. If not, then we will go for others. Okay, you check for parallel connection. I think you can get a parallel connection here by considering the 1 farads, 1 farads and 1 ohms, which is one type of T network, and this we can consider as N1 or N2, whatever it is. And we have another network with another elements like 2 ohms, this 2 ohms we have, and these 2 farads we have. Fine. All these two values of elements are also forming one more T network, and this is connected in parallel with the other network which is having the elements of ones, right? So then what we can do? So we can consider one network N1 with 2 ohm and 2 farads. And then how to proceed? Since capacitor value is there, are we going to proceed with time domain approach? No, we should not do that because we need to assume that the elements are in steady state condition. So whenever the elements are in steady state condition, mainly the inductor and capacitor, we need to proceed with the approach of Laplace domain. Yes, then what is the value of capacitor in Laplace domain? It is 1 by Cs. So that's why we have written here 1 by 2s. Fine, right? So 2 ohms will be 2 ohms and 2 ohms will be 2 ohms. That's fine. Right, now you need to get the y parameters of this simplified network, which is a part of the overall network. So it is easy to get. For that you directly follow the y parameters equations. Otherwise you can also get the current equations, which we can compare with the y parameter standard equation for getting y11, y12, y21 as well as y22. So these all things are based on KCL or KVL. I'm not going to discuss about this. I just would like to tell you the procedure of determining overall networks parameters based on the connections, right? Okay, you can get y parameters of network N1. Let us say this is for network N1, right? Fine. Next, it is not the complete overall network's y parameters. So we also have another network which is connected in parallel with this network, and that network is having values of 2 capacitors and 1 resistor connected in T type. So now you need to consider that network as N2, and here again we need to proceed with Laplace domain. Then it will be 1 by Cs, that is 1 by S, 1 by S and 1, right? So for this N2 network, again you need to determine y parameters. Fine. So again this is the procedure which can be done using either KVL or KCL. So once you get the y parameters of N2 network, what you can do? You can add both the network's y parameters to get the overall network's y parameters. It is already derived. So the overall network's y parameters will be sum of the individual networks y parameters. So you don't worry about the Laplace variable s. Since there is capacitor involved in the given network, we will always get result in Laplace domain only. In s variable format only we will get the result. Don't worry about it. Fine. So this is about the networks which are connected in parallel, right? In a similar manner you can have different networks connected in either series or cascade manner. So accordingly you need to proceed to get the required parameters, right? So that's it for this lecture. Thank you.